Alright, for this function we're going to find the intervals of increase, decrease, the local maximum and minimum values, the inflection points, and then also where it's concave up and concave down. So to start doing the intervals of increase and decrease, we are going to take the first derivative of it. So we have f prime of x equals, bring the 4 down, divided by 2. So we're going to have 2x lower the power by 1. That's using the power rule. Minus, same thing here, power rule. We have 8x. 2, since it's a constant, it becomes 0. So that's going to be the derivative of the function. Let's see if we can focus a little better. Okay. So there is our derivative. Once we have the first derivative, we need to find the critical points. We get the critical points by setting the function equal to 0. So we're going to have 2x to the third minus 8x equals 0. We can take a 2 and an x out of both of these. So we're going to do that. 2x left over, we have x squared minus 4 equals 0. So we have both of these. To get this fraction equal to 0, for this one we can either have x equal to 0, or for this we can have x squared minus 4 equals 0, x squared equals 4. Taking the square root of both sides, we have x squared equal to plus or minus 2. So those are going to be our 3 critical points. So we have 0, -2, and 2. So now we need to check these to figure out the intervals of increase. So we're going to have -infinity to -2. We're going to have -2 to 0. And we're going to have 0 to 2. And then one more will be 2 to infinity. Okay, so for -infinity to 2, all we have to do is pick a number between there. So we're going to do -10 to make it easy. Now we're going to plug that in to our first derivative. So we have -10, plugging that in here to the first derivative, that equals negative. All we care about is if it comes out to positive or negative, and it comes out to negative. When we plug in between -2 and 0, we'll just do -1. When we plug in -1 to the first derivative, right here, we get a positive number. Then for this one, 0 to 2, we'll just take what's in between, 1. When we plug in 1, we get a negative number. And then for the last one, 2 to positive infinity, we're going to take 10, and we get a positive number. Okay, so what this means is this function, the initial function, is decreasing between -infinity and 2, and also between 0 and 2. And it's increasing between -2 and 0 and 2 and infinity. So that's going to be our answer. So for increase, we have -2 to 0, and then also we have 2 to infinity. And then decrease, is going to be -2 infinity to -2, and then also our 0 to 2. And that was found by taking the critical numbers. So next up, we have to find the local minimum and maximum values. For that, all we're going to do is plug in our critical numbers. So again, our critical numbers were 0, -2, and 2. And all we're going to do is plug those into our original function, which is up here. So 0, when we plug 0 in, we get 2. When we plug -2 in, when we plug -2 in, we get -6. And then when we plug in 2, we also get -6. So we're going to have 2 being our local max, and -6 is our local minimum. Okay, so that takes care of the first part of it. Now next up, we need to find the inflection points. Inflection points come from the second derivative. So again, what we found out on the last page is that our first derivative is equal to 2x cubed minus 8x. So taking the second derivative, same way to take the first, using a chain rule, we're going to have 6x minus 8. This is defined everywhere for x, so we need to set it equal to 0. And then just solve for x. So we have x equal to 8/6, and that is equal to 4/3. Oh, I made a mistake here. This is 6x squared, this is 6x squared, 6x squared. So you have x squared equal to 4/3, so that means x is equal to the square root of 4/3. Square root of 4/3 is plus or minus 2 times the square root of 3 over 3. Okay, so these are going to be our two critical numbers for the second derivative, plus 2 times the square root of 3 over 3 and minus 2 times the square root of 3 over 3. So we need to set up our intervals again. Since it's defined everywhere, we're going to have -infinity to -2 square root of 3 over 3. And we're going to have -2 square root 3 over 3 to 2 square root 3 over 3. And our last one will be 2 square root 3 over 3 to positive infinity. Okay, so picking a number between this, we will use -10. For the middle one, we'll use 0 to make it simple, and for this one, we'll use 10. All we have to do is just find some number between each of them, and 10s and 0s are the easiest, I think. So we have to plug these numbers back into our second derivative. When we plug -10 into our second derivative, we get a positive number. When we plug 0 into the second derivative, we get a negative number. And when we plug 10 into the second derivative, we get a positive number. Okay, so what this means is we're trying to find concavity. When the second derivative is positive, that means it's concave upward. So between -infinity and negative 2 times the square root of 3 over 3, and then also 2 times the square root of 3 over 3 to positive infinity. Those are both going to be concave upward. And then negative 2 times the square root of 3 over 3 to 2 times the square root of 3 over 3, that's going to be concave downward. So for up, we have negative infinity to the negative 2 square root of 3 over 3, and for up we also have this. So those are going to be the two where it's concave up, and for concave down it's going to be the middle one, which is negative 2 square root of 3 over 3 and 2 square root of 3 over 3. Okay, and then we need to find our inflection points. Inflection points are when it switches from concave up to concave down. So to find those, we already know where it switches. It switches at plus and minus 2 times the square root of 3 over 3. So when it's positive, 2 square root of 3 over 3, and when it's negative, square root 2 times square root 3 over 3. Yes. Get that focused again. All we're going to do is plug both these numbers into our original function. Not f prime, not f double prime, but the original f. The original f being this one right here. So f of x equals 1 over 2 x to the 4th minus 4x squared plus 2. Okay, then we plug, there we go. So plugging both these numbers in, we're going to have, for the negative one, when you plug that in, you get negative 22 over 9. And since our original function is even powers, it's going to come out to the same. It doesn't matter whether x is positive or negative, since it's squared and also quadded, it will come out even, or it'll come out to the same either way. So we're going to have negative 22 over 9 for both of these. So our two inflection points are going to be our x values, negative 2 square root 2 over 3 and negative 22 ninths. And then our second inflection point is going to be positive 2 square root 3 here. Square root 3 over 3 and negative 22 ninths. So those are both going to be our inflection points. Okay, and that's how you do that.